Hi, welcome. In this video, we will solve problem longest consecutive sequence asked by companies like Amazon, Microsoft, and Facebook. Now let's check out this problem, longest consecutive sequence. It is the most important problem, and this problem is asked in many interviews. Okay, so if you are thinking one of the problem that covered the fundamentals of sets, data structure, hash maps, sorting, this can be one of the problem that you can add in to your bucket list. So now let's see what we need to find. So given an unsorted array of integer nouns, return the length of the longest consecutive element sequence, right? Consecutive means one by one, right? So I want the longest consecutive sequence of elements, and we must to find an algorithm that runs on big O of n time complex. Okay, so here you can see one of the example is given 100, 4, 200, 1, 3, 2. So if I found the one of the sequence, right? So 1, right? Then after that I have a second number that is 2, then 3, then 4, and all these 4 numbers I can find in my input array. But if I'm checking for 5, 5 is not present, right? So the longest consecutive sequence here I am getting, that is 4. That's why the output is 4. And here you can see, so if I am starting from 0, so I will get 0 here, then 1 is also present, then 2 is also present, then 3 is also present, 4 present, 5, 6, 7, 8, and yes, only the 8 is present. Okay, so here I am getting the longest sequence as of 9 elements, and that's why the output is 9. So now let's see how we can solve this problem, what are the possible solutions that we can apply here. And let's take the same test case first. So we have 100, 4, 200, 1, 3, 2, right? So when this is my array, right, let me put the indexes 0, 1, 3, 4, 5. Let's suppose this is my array. So how can I solve it? Okay. What can be the possible approach? So we will discuss about all the approaches first. Okay, so let's cover the first approach, that is the brute force approach. Okay, so if I think in brute force, that means that the first approach that comes to my mind is I will take one element. Let's suppose I am taking 100. I will take 100 and I will find the next element of it, that is 101, in the complete array. In the complete array. Here you can see I can't find 101 here, so I will simply leave that. Okay, then I will simply find the next element 4. Okay, and I will find the next element of it. Okay, because 4 is present, I will find the next element of it, so that is 5, and I will again search in the complete array. So no element is present, again 5, so I will simply leave that, and I will take one more element. Okay, the next element, that is 200. Okay, and I will find the next element is present, 201. So again in this complete array search, I won't be able to find 201, so I will simply leave this. Then I will check out the next element. Okay, that is 1, and here from this is interesting. So I will find 1. Okay, and I will find the next element of, like, what will be the next number of 1, that will be 2, and I will find in a complete search is 2 is present, and yes, it is present. So what I will do, I will update my count. So count, because 1 was already there, now I got 2, so count will be now from 1 it will shift to 2. I will start from count with 1. So I will start with 1 and I will update to 2. Okay, now I got 2. From 2 I will again find the next number is 3 is present. So again I will do a complete search here, right, for 3, and I will find 3 here. So what I will do, I will again update the count. Then what I will do, again I will take the same number. Okay, again I will increase the number by 4, and I will check is 4 is present. Yes, it is present here. So what I will do, again I will update the count to, again what I will do, I will update my number by 1, increment by number by 1, that will be 5. I will find out is the 5 is present here in the array. No, it is not present. So what I will do, I will simply stop it here, and this will be my final count, that will be 4. So we can apply this approach, right? This is one of the brute force approach. Like it takes a good amount of time. Okay, your interview won't be impressed by this approach. Okay, it has a very high time complexity, but yeah, that's a first approach you can simply propose to your interview. Okay, now let's see one more example to better understand this brute force approach. So put all these things here. Let's take one more example here. Now let's see this example. So first of all, let me add the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, and again we will solve with the same brute force approach. So how I will solve it? So again, if you missed this something in the last example, you can take this example. And so here, what I will do? Again, I will take one element. Okay, I will get 1, and I will find like is 1 plus 1, that is 2, is present in my complete array, right? Again, my count will start from 1. Okay, so 1 plus 1, 2 is present in complete array. Yes, it is present. So what I will do, I will update my count 2. Okay, now I will find is 3 is present here in my complete array. No, it is not present. So the maximum count I will get, that is 2. Okay, and I will leave and I will move it. Okay, when I'm moving it, okay, I will simply update in my maximum or longer that I 2. Okay, and I will again start from 1. Now again I am getting 1, right? So I will again check for 2. Is 2 is present in the complete array, right? And yes, it is present. So again I will update it to 2. And from 2, again I will move to 3. Is 3 is present in my complete array? No, it is not. So again the maximum count I got 2, and the maximum will be 2. Okay, so again I will move it. Okay, and again my count will start from 1. So let me put it this be 1, and again I will start from here. So that will be 2. So from 2 I will check is like from I got 2, from 2 to I will check 3 is present. No, it is not present. So what I will do, I will simply move it. Okay, now I got 7, right? So I will take 7 and I will find for 8. Is 8 is present? Yes, 8 is present. So I will update the count to 1, not to 2. Now what I will do, I will update my number to 9, and from 9 I will check is 9 is present in the array. Yes, it is present. So I will update the count to 3. Now from 9 I will change my number to 10, like simply incrementing the number. 10 is present. Yes, it is present. So I will update the count to 4. Now from 10 I will increment my number to 11. Is 11 is present in my array? Yes, it is. So I will update it to 5. And from 11 I will check is 12 is present. No, it is not. So now the maximum count I got, that is 5, and I will update my maximum, it will be 5. Then again I will check 11 and I will do the same. Okay, again I will take 11 and I will find for like is 12 is present. No, it is not present. So again count will start from 1. Then same for 0, I will check for 1, 0 and 2, we will get 3. So the maximum count I will get here, that is 5. So this is one of the approach that you can apply here, and that is the brute force approach. Okay. Let me show you how you can implement this brute force approach, a basic code of it. So what we will do, we will again take one by one element. So I will start from 0 to the last element. Okay, and from here I will take my one element. So suppose my element will be array I, and I will update the count equals to 1. Basically I am starting with 1, and I will create one function. Okay, that is one function find. Okay, that will find the element that you are suggesting. Suppose like whatever your element is, let's suppose n. So basically it will find there. So I will simply mention for I will start from again 0 to n, the length of the array, and if here in this complete array, in this array, if I am getting array I is equals to my element, that is n, what I will do, I will simply say return true. Okay, that I found it. Basically it is a linear search. This is your method is a linear search. Okay, you will find it, and if suppose I am not able to find it, so here I will return false. So now same function I will use it here, that while I am getting this element that is find, okay, and I will pass the array and I will pass the element x plus 1, right, increment number. I will pass this one, and if it is returning me true, so I will simply run it. Okay, I will simply run. And I will update my number one by one. So x will be x plus 1, and I will update the count. Count will be count plus plus. Okay, and basically this will move. This will run again and again, again and again, and eventually we will get the maximum answer. So here, like if you want, so here you will get the count. Whenever it will come from while loop, you can simply say if your count is greater than your maximum, whatever, suppose you started your max with minus infinity. Okay. So if it is greater than max, you will update your max to the count. Okay, and rest will be your I pointer will again and again. So basically this will be your brute force approach. Here your linear search will take how much time? It will take n time, right? And we have while loop, right? So suppose one of the extreme case that I am incrementing number from 1 to 2 to 3 to 4 and finding all the numbers, right? So this will also take n times, right? And this is also taking n times, right? So we have for, inside for we have while, and inside while we are finding again with a for loop. So the total time complexity here will be big O of n cube, right? If we go till that direction, again it is nearly to n cube, right? Why I'm saying nearly, not exactly equals, because in extreme cases you will find it, right? In extreme cases you will find that you are going till the last element, right? It is not in the all the cases. So time complexity will be big O of n cube and space complexity will be big O of 1. Here we are not taking any space, but yeah, this will be your one of the brute force solution that you can propose to your interview, and your interview won't be impressed by your answer again. So we need to come up with a bit more optimized approach. So now let's see the next approach, what we can do in the approach 2. Now let's check out approach 2. So in approach 2, what we will do, we will sort the array. So I have this given as an array, mention this as an array, and what I will do, I will basically sort this array. So if I sort this complete array, what will be my sorted array? So I will start from 0, then 1, 1, 2, then 7, 8, 8, 9, then 96, 87, 88, 9. This will be my array and these will be my indexes 0, 3, 4, 5, 6, 7, 8, 10, 11. So what is n? N is 2 here, 14 here, 14 elements. Okay. So why we have done sorted, right? Why we did sorted? Because when we sorted, right, we need to find consecutive sequence elements, right? Consecutive. And when we did sorting here, right, we can get the consecutive elements. You can see here we have some continuity 1, 2, 7, not here, like here 7, 8, 9, 9, 96, 97, 98, 99, 100, 101, right? So there is some continuity, and that's why we basically sort it. And from sorting we get a lots of ideas like what we can implement, what are the new things that we can implement here. Okay. So what I did, I basically sorted, and now what I will do, I will take each element one by one. So what I will do, I will create some variables, like I will take the track of my last smaller. Okay, what was the smaller element? Suppose I started with minus infinity, and I will take one element, right? So let's suppose I am taking 0 element, and then what I will do, I will compare. Okay, first of all I will subtract 0 minus 1, so I will get minus 1, then I will find out the minus 1, so I got minus 1. Then what I will do, I will now compare with my last smaller. Okay, is my last smaller is minus 1. So why I am comparing, why we are doing this? So basically I want to find a pattern, a sequence, right? So when I am doing 0 minus 1, And if my -1 is the last smaller, I will say that 0 is in the sequence, right? 0 is the required element, right? But if -1 is not the smaller one, that means 0 is from like a new element. So let's create it. Okay, so then you will need to know. So what I will do, I will take this as an I, and this will be my array I -1, sorted array. Okay, and this will be my last smaller, and let me increase the size. Now let's check. So this is my first element 0. Okay, I will check what is my array I -1, right? So 0 -1, that will be -1. I will check, is it my last smaller element? Last smaller is -infinity. So what I will do, I will change my last smaller. Okay, because if it is not equal, so I will change my last smaller to the current element, that is array I, that is 0. I will change it. So my last smaller will be 0, and now my count will be 1. I will start the count from here. Now let's see. So then what I will do, I will take one element here. So this is 1. Okay, again I will check what is my array I -1. First of all, 1 index. What is I -1? That is 1 -1. That is 0. So is 0 is my last smaller? Yes, it is. So that means the one that we are discussing about, that one is one of the sequence. We can take it, right? So what I will do, I will take this one and I will simply update my count. So my count will be 2, and now my last smaller will be changed to 0 to 1. Okay, but my count is increasing, right? So my last smaller will be now 1. Okay, again I will move forward. Now again I am getting the same 1, but index is different, so it is now 2. What is array I -1? That is again 0. Array I -1, 0. But is it equal to your last smaller? No, it is not. Okay, it is not. But the element, the element, the element that is here of I, can I say that it is equals to my last smaller? Basically, it is equals to my last smaller, right? What is last smaller? That is 1. Last smaller is 1. And element is also equal. So can I skip this element? Because this is already counted. Okay, this is not in the sequence, so I can skip this. I will skip this and I will move forward. Okay, so now what will my I will be at 3. What will be array I -1? 2 -1, that will be 1. Okay, and I will check here, that is array I -1 is equals to my last smaller. Yes, it is. So what I will do, I will read the count. Count will be now 3, and I will update my last smaller. Now the last smaller will be 2. Here the last smaller will be 2. Now again I will move further. Okay, now I am getting 4th index. I will check what is the element, 7. What I will do, I will do 7 -1, that will be 6. Is it equals to your last smaller? No. So can I say what I was finding, consecutive sequence? Can I say that this is the end of my consecutive sequence? Here 0 1 2 was the only consecutive sequence because it is not equals to my last smaller. So what I will do, I again now change my last smaller. So I will change my last smaller to the current element, that is 7, and I will again start my count with 1. So here the maximum count I got, that is 3. Okay, now the last smaller is changed to 7. Again I will move. Okay, what is the index? The index is, now you will get to know how this is working. So I is 5. What is the element? That is 8. Okay, so 8 -1, that is 7. Is it equals to your last smaller? Yes, it is. So yes, this number is in the sequence, right? So I will take it. So 8 -1, that is 7, which is equals to my last smaller. What I will do, I will update the count and I will update my last smaller to 8. Okay, again I will move forward. Okay, again I am getting 8. 8 -1, that is 7. But is 8 is equals to your last smaller? Yes, 8 is directly equals to your last smaller, right? So can I say I can skip this element? So what I will do, I will please skip this. I got 9, right? So index is 7. Index is 7. 5th index is done. 6th is also done. 7. What that is 9. Now when I am getting 9, I will do a 9 -1, that I will get 8. Okay, and I will check, is
equal to my last smaller? Yes, 8 is equals to my last smaller. So can I say that I can take 9? Yes, I can take 9. So 9 minus 8, which is equals to my last smaller. So I will update the count. We now 3, and my last smaller change to now change to 9. Okay. Now here, what I will do again, I will move to the next element, 96. Now you will get it. Okay, how I am starting it again. I am getting 96. What is 96 minus 1? That is 95. Is 95 is equals to your last smaller? Right, the index is 8. 96 minus 1, that is 95. Is it equals to your last smaller? No. So can I say the sequence is now ended? What was the sequence? I was starting from 7, 8, 9. This was the maximum sequence that I was getting. It is ended now, right? So what I will do, I will again start it. I will make my last smaller to 95, and I will again count from 1. So the maximum count here I got, that is 3 only. Okay, again we'll start. Okay, so again now you will get it. So let me just increase the size. Now let's see. So here my 8 index is done. I will move to 97. Okay, it is 9th index. What is 97 minus 1? That is 96. Okay, so I will update. First of all, it was 96, so I will update with 96, not 95. Current element. Okay, it was 96. I will check 97 minus 96. Is it equals to my last smaller? Yes, it is. Yes, it is. So it is 96, which is equals to last smaller. I will update the count. Okay, and my new last smaller will be the current element, that is 97. Okay, now I will move to the next index, 10. What is the element? 98. What is 98 minus 1? 97. Is it equals to your last smaller? Yes. Update the count and update your last smaller. My last smaller will be 98. Here I will move to 11th index. Okay, what is the element? 99. 99 minus 1, that is 98. Is it equals to your last smaller? Yes. Update the count and make your last smaller to 99. Again, what I will do, I will move. Okay, what will be the new index? That is 12. Okay, what is 100 minus 1? That is 99. Is it equals to your last smaller? Yes, it is. So what I will do, I will update the count to 5, and I will make the last smaller, that is 100. Okay, again I will start from 13. I will take, what is the element? 101 minus 1, that is 100. Is it equals to your last smaller? Yes, it is. So what I will do, I will update the count to 6, and I will make this 200. And yeah, that's the end of the loop, right? That's the last loop we can reach, and the maximum count that I am getting here is 6. So the answer is 6, the largest count of 96, 97, 98, 99, 100 and 1. Okay, so this is how we are basically. So you can see, right, what is the error approach. So if I simply read this, just tell you what are the steps what we are doing here. So we are maintaining one last smaller. Okay, we are maintaining one last smaller, and we are comparing the ith minus 1 term with the last smaller. Okay, we are comparing with array I minus 1 with the last smaller. If this is equal, right, if both are equal, that means we can move this element, the ith element can be in the sequence. If it is equal, that it can be in the sequence. If it is not equal, what we are doing, we are again starting the count with 1, and we are changing our last smaller to the new element. Okay, so if I write a pseudo code of, okay, so let me the pseudo so that we get some out of idea. So first of all, what we will sort the array. Okay, so I will sort array, and after sorting, we write it right. So I will simply run a loop that will start from 0 n step 10, and here I will write few conditions. Condition is if the element is equals to your last element. So the current element is equals to the most smaller. Okay, what I will do, I won't do anything. I will simply say continue, move it. Okay, we don't know anything. Simply move it. The next case is if your element area minus 1 is equals to the last is smaller, we will simply do few things that you can mention here, that because it is equal, right? That is in the sequence, so I will count it and I will update my last small will be the element area. Okay, else if it is not equal, else like if it is not equals to last is smaller, what you will do, you will initiate a new process, right? You will count, start with 1 and your last is smaller will be the again new element. That's it. And here just like after each iteration, what you will do, you will find the maximum, right? How you will find the maximum? Basically you will take the max of count and max, right? We are counting, you will take the count on max and you will return. So what will be the time complexity of this approach? So for sorting, take big O of n log n, right? And this will take n times, right? And again here, this is only if else condition, right? So the total will be big O of n log n plus big O of n, and which has the which has more, which takes more time. So this takes more time, right? This is maximum, right? So we are going to take this one. Okay, we from here I will take the max of it, of n log n time we take. So the time complexity of this approach will be big log. Here we are not taking any extra space, so the space complexity will be big. So this is one of the approach that we can try. Now again, we can further optimize it, right? If we can further optimize it, so let's check the new approach, that is approach 3. We can further optimize it. First of all, are you finding any type of repetitions here? Any types of repetitions that we are? No repetitions. The only thing is sorted, right? We sorted it and now we are getting the sense. So whatever the logic that we have created, we get to know just because of sorting, because we sorted the data. We have sorted the data, that's we can compare the adjacent element last is smaller and array I. But if the data is not sorted, right? And if you are not allowed to do sorting, then how you will do it? So that's our approach 3, how we will do it. So now in approach 3, what we will do, we will use again, right, frequency table, or JavaScript we called it as objects. You can say it's hash map, dictionary. Okay. So we basically why we are doing, so that we can easily find out the element, right? So suppose there is a count of 1 and I want to find 2, is 2 is in my array. So I don't need to do a linear search. What I will do, I can quickly check in my object that is it present or not. So what I will do, first task is I will create an object. Okay, create an object. Let me write that this will be my object, create key with here. Okay, and I will store all the elements. So I will store 0, frequency of 1, then 2, frequency of 1, 1, frequency of 2, then 8, frequency of 2, we have 7, 1, then we have 9 frequency, then we have 96, 1 frequency, 97, frequency 98, 1 frequency 99, 1 frequency 100, 1, then 1. Okay, so these will be the all the elements. And now what I will do, in the object, in my map, okay, what I will do, I will check each element one by one. What I will do, I will take 0. Okay. So I will take 0 first. I will check is 0 minus 1, that is minus 1, is this present in my object? Why I am doing so? First of all, why I am doing so? Because I want to start with the lowest element. I want to start my iteration the lowest element. So suppose there is 1 0 1 2 3 4 and there is 1 2 3 4, right? So suppose I somehow come to this one 3. So what I will do, I am thinking that instead of starting with 3, I will start from 0 so that I will get a complete sequence that how many elements, consecutive elements, that we have 5. If I'm accidentally dropped to 4, what I will do, I will go to the lowest element possible, that is 1, and I will count. So the elements we will get, that is 4. So that's why I am finding the eth element, that my element -1. Okay. So you can see here in key -1 in the object. So 0 minus 1, right? I will check is -1 is present. No. So can I say my 0 is the lowest element of the sequence, of the longest consecutive sequence? My 0 is the lowest element. Yes. So what I will do, now I will start from 0, right? So now I have 0, and I will simply add 1. So I will get 1. I will check is 1 is present. Yes, it is. 1 is present. So what I will do, I will update the count. So I again here I have started my count with 1 and I got 0, that was 1. Now 0 plus 1 is also present. So now the count is 2. And now what I will do after this, I will do 1 plus 1, that is 2. Is 2 is present? Yes, this is also present. So what I will do, I will update to count 3. Now I will do 2 plus 1, 3. Is this is present? No, 3 is not present. So what I will do, now I will stop it and I will update my maximum. So somehow, suppose I am storing my maximum will be 3. Okay, then again same thing, I will start with the new element, new count will be 1, again start from 1. Okay, I will start with the next element, I will take 2 and I will check is 2 minus 1 is present. First of all, e minus 1, 2 minus 1 present, that is 1. Yes, it is present, so I will leave 2. What I am thinking here, that I will take the lowest element of the sequence and I will start iteration, so I will leave 2. Okay, then I will check 1. Is 1 minus 1 0? Is it present? Yes, it is present, so I will leave it. Then I will take 8. I will check is 8 minus 1, that is 7, is present? Yes, so I will leave it. 7 is 7 minus 1, that is 6, present? No, it is not. So can I say my 7 is the lowest element here of the sequence? So I will start from 7. Okay, and what I will do, I will take 7 and I will find is 7 plus 1, 8 is present? Yes, it is, right? 8 is present. So what I will do, I will update the count to 2. Now I will do 8 plus 1 is 9 is present? Yes, it is. So I will update the count to 3. Then I will check is 9 plus 1 10 present? No, it is not, right? So what I will do, again I will start the complete process. Okay, again I will update my maximum, and here the maximum will be the same, that is 3. Okay, and count, again I will start new count. So I will take count from 1. Okay, and 7 is done. Okay, because we are not able to find 10, so I will remove the element. I will check 9. Again I will check is 9 minus 1, that is 8, present? Yes, so leave it. Now check 96 is 96 minus 1, that is 95, present? This is not present. So can I say my 96 element is the lowest element here? 96 element is the lowest element? Yes, it is. So what I will do, this is the lowest element. I will take count is 1. 96 plus 1, 97. I will check is it present? Yes, it is. Did the count 2. Now 97 plus 1, 98. Is this present? Yes, it is. Update to count to 3. Now 98 plus 1, 99. This present? Yes, it is. Update to count to 4. Now 99 plus 1, 100. Is this present? Yes, it is. Update to count to 5. Now 100 plus 1, that is 101. Is this present? Yes. What I will do, I will update the count to 6. Okay. So here what I will get the sequence 1, 2, 3, 4, 5, 6 consecutive elements and update my maximum. So now my maximum will be 6. Again, this is done, right? So after this, I won't be able to find it. Suppose let's continue the same. 101 plus 1, that is 102. Is 102 is present? No, it is not. So again, we will start count with 1. Count with 1. And again, we will take the elements. Yeah, right. So again I will start with 97. I will find 97 minus 6 present, 97 minus 1, that will be 96. Is this present? Yes it is, so leave it. 98 minus 1, 97 present, leave it. 97, 99 minus 1, 98 present, leave it. 100 minus 1, 99 present, leave it. 101 minus 1, 100 present, leave it. So that's all, I leave it all the elements, and the maximum count I will get here, that is 6. So yes, this is one of the approach that we can apply, and we can check the pseudocode of how the pseudocode. So what I am doing here, so I will say first I'm storing in my object, right? So I will store in object. Okay, this is the first step, and then what I will do, I will simply run a loop or simply iterate the object, right? So for key in object, I will simply run the object. We'll start with count of, we'll start with count 0, count of, will change on the basis of like how your iterations are your. So what I will find key now, just my count with 0. I will check that if the key minus 1 wala loop, right, key minus 1 is present in my object, right? So if this is present, right, this is present, what I will do, I will say continue, leave it, and while what, suppose I will come here when key minus 1 object is not present, so I will come here, then what I will simply check if this is present or like it is not equals to undefined. So simply what I will do, I will update my key will be key plus 1, I will update the count will be count plus plus. Once come from the while loop, check the count greater than max, then I will max equals to count greater max. This is one of the this is pseudocode of, okay. We'll see the time complexity. So I am simply storing the object that will take, if all the elements are unique, take big O of, okay, time, like even if all the elements are not unique, still like it will take big O of n because we are storing all the elements here. Now I am iterating the all the elements, right? So this, right, this is separated. I am iterating in all the elements, and if all the elements are unique, then this is going to take big O of n, right? And now what you are doing, you are like hereby simply checking the elements. So suppose we are taking the last case, taking this case. So here you can see I stored all the elements, so it will take big O of n, and now I am checking one by one each element. So suppose in one of the case I will iterate through all the elements, right? That will take n times, okay, and in n times one time I will also count, suppose in any of the element, or if you consider the worst case, I will check this while loop. So this will also run for n times, right? But it won't run for all the elements, not possible. It won't be run for all the elements, it will run only single time here, okay, like single or double, like only it will check what is the count, right? So like here you can see this is n, so how many times run here, so first run 3 times, then 3, then 6, so 3 plus then 3 plus 6, so it is 9, and that is 30, okay. And what was your n? That is also 30, okay. Here how many elements were there? That is also 30. So the most probably chance that it will run for 2n, nearly equals to 2n, okay. And again this is a constant, so the time complexity will be big O of n, we can simply ignore the constant, so the time complexity here will be big O of n, and space complexity will be again big O of n if all the elements are unique, then the space complexity will be big O of n. So yeah, This is one of the way that you can apply here by using set data structure, by using objects, you can find it. Now, in the next video, we will see the implementation of all the three approaches that we have discussed. Okay, we will discuss mainly two approaches because these are more fruitful, and so we will see the code implementation.